Hi, welcome back. I actually tried to do this one a little bit earlier today, but the puppies kept barking. So you're going to get an interesting summary of 8.2 this evening. So welcome back. This is Math with Business Applications. We are in Unit 5 currently, looking at merchandise pricing and a little bit of payroll. These are chapters 8 and 9 out of your e-text. Today we're going to be looking at markup based on selling price. Markup based on selling price is out of chapter 8, section 2. So our goals for this particular section are as follows. We want you to be able to calculate the percent markup based on selling price. With that there are some alternate calculations you should be able to make. You should be able to calculate the selling price when the cost is known and the percent markup based on your selling price is also known. We're going to ask that you are able to calculate the cost of an item. Again, when the selling price is known and when the percent markup based on that selling price is known. And then lastly, we want you to be able to convert between the different markups. So in Chapter 8, Section 1, we did markup based on cost. That is when you mark up a problem or you mark up an item or a good or a service based upon what it costs you to provide it. And then today, what we're going to do is markup based on selling price. So this is markup based on what you know the market will hold. One of the examples I use for that is Burger Fusion, which now only has a truck, unfortunately. When they first opened years ago, 10 years ago, 9-ish years ago, I was 100% certain that nobody in town was going to pay $9 for a burger, let alone $13 for a burger and fries or burgers and tots from what was essentially a fast food place. But the fact of the matter is La Crosse did. Like, we paid that amount. So that's a situation where a restaurant or a service was looked at and they said, okay, here's how much this area will max out. They won't pay anything more than X amount of dollars for this. And then they backtracked to figure out what their costs had to be based on that. So they knew their markup, they figured out their cost based on their selling price. So we're going to take a look at that, the percent markup based on selling price. And as with the example I just gave, the percent markup based on selling price is a markup that is generally used by retailers, so the customer or forward-facing stores. This is known as a margin because it is the difference between their cost and the selling price. It is sometimes not just called the markup, but it is called the margins. So when you're dealing with a markup based on selling price, that is sometimes referred to as their margins. They want their margins to be profitable. In other words, they want the extra that they charge to be profitable. Okay. In a markup based on selling price, the selling price is the base. It is the 100%. The margin or markup is a percent or portion of that selling price. We find a portion using rate times base. So what it comes down to is our percent markup is our rate. The dollar amount of the markup or margin is our portion. And the selling price is our base. If it sounds familiar, that's because this too works off the idea of the percent triangle, where P portion is the amount of the markup, where the R rate is the percent of the markup. Only this time our base is the selling price of the item. And so while the three basic formulas from the percents were the same, the portion is the rate times the base, the rate is the portion divided by the base, and the base is the portion over the rate. What's changed in this example is what we are using as our base. Okay. Here's a problem to try. Buzz buys kayaks from a distributor at $219 each. The kayaks will sell for $479 each. What is the amount of the markup and the percent of the markup based on the selling price? we can still use the chart and proportions, the same as we did with markup based on cost. We're still going to use the same basic chart. The cost plus the markup is equal to our selling price. So our retail equation doesn't change. The cost plus the markup has to equal the selling price. Our second column is the dollar amount, and our third column is the percent. I think I switched the order. The order doesn't matter. We could have switched it back to percent and dollar amount, but what has to happen in this case is because it is a percent markup based on selling price, our selling price percent is the 100. It's not the cost percent like it was before, because that was a markup based on cost. This is a markup based on our selling price. So since selling price is our base, that's what we're comparing everything to. That's what we're comparing the markup to. So that's going to be our 100%. Mining the rest of the information from the word problem, I can see that the cost for buzzes was $219. I can see that they sell for $479. So the amount of the markup is going to be the difference between the cost and the selling price. So if I take $479 and I subtract $219, that will give me the $260 as the markup. Now, I've got the amount of the markup. I am also supposed to find the percent of the markup based on the selling price. So the percent of the markup is my X value. And looking at this, I can see that the bottom 4 spaces, there we go, the amount of the markup is 260. I knew that was in there someplace. I can see that the bottom 4 spaces I can use to set up a proportion. So I can do 260 over 479 is X over 100. I can cross multiply this to get X is 54.2797495, and I've got my value of X. Now, I can also do this using the formulas. And if I use the formula, what I'm looking for is a percent or a rate. So I can use the basic rate is equal to the portion over the base. However, my rate this time is the percent markup based on selling price. That's a comparison of the amount of the markup to the selling price, or 260 over 479, which, if I just use 4 decimal places, is 0.05428. This is enough because I'll need to multiply that by 100 to get the percent. And notice that in both cases, we end up with 54.3% if I round it to the nearest tenth. All right, moving on to the next one. In Chapter 8, Section 6, we're going to look at finding the selling price when the markup is based on selling price. I don't know why that says cost. When markup is based on, let me get this. Selling price. I'll need to fix that. Okay, when markup is based on the selling price. All right, good. So we know that the selling price is cost plus whatever markup we're assigning based on selling price. Notice that selling price is the base, and we know that the markup will also be a rate or portion of the selling price. So that means we're going to use 100% of the selling price, and that's going to be the cost plus the markup, which we already know is another percent of the selling price. Do you see how we've got selling price on the left side of the equation and selling price on the right side of the equation? I'm going to sneak a little algebra in here, and I'm going to subtract the markup percent of selling price from both sides of my equation so that I have the selling price then on the same side of the equals. I've got 100% of the selling price and the markup percent of the selling price. And if I subtract those, I get a cost. Now, just like last time, do you see how we've got selling price in both of those pieces? I can pull that out front. And if I pull that out front, then in the first piece here, I'm left with 100%. There we go. And in the second piece, I'm left with minus whatever the markup percent is. So I end up with a formula where the selling price is pulled out front, and I then multiply that by the difference from 100 and the markup percent, or the complement, if you would rather, of the markup percent. So my formula is that the selling price would then be the cost divided by this whole set of parentheses. If I'm looking for the selling price, then in order to get it alone, I'm going to take this whole piece and divide the cost by it, whatever that percent might be. All right. This gives us our new formula. Here we go. Formula. Come on, baby. Formula. There we go. All right. How do we use this? Well, we can, again, with a slightly different problem. We've got Michael's Menswear purchasing suits for $85 from a manufacturer. They use a 90% markup based on selling price. That's their objective. That is, that's what they're going for. What should their selling price be? And again, if you like the table or the chart, you can use it. The cost plus the markup has to equal the selling price. Since this is a markup based on selling price, we need to make sure to put a 100 in the percent of the selling price, because the selling price is our base. It gets to be the 100%. Mining information from the problem itself, we get that the cost of the suits is $85. We know that the percent markup is 90. Now, the cost plus the markup has to equal 100%. So I have the 90. I know the cost percent then had to be 10%, because what plus 90 is going to equal 100? I'm supposed to find the selling price. What will the selling price be? So the selling price is my X, or unknown. That's the cost in dollars. And if I use the first row and the bottom row, I can put together a proportion that says 85 over X is 10 over 100. Cross multiplying and then dividing both sides by 10, I get that the selling price, or X value, should be $850. That's an expensive suit. Using the formulas, I should get the same answer. If I use selling price is equal to the cost divided by the complement of the markup based on selling price, that means when I put in the values, the cost was 85, the markup based on selling price was 90. So I'm going to have 85 over 100 minus 90%, or 85 over 10%, which is 85 divided by 0.10 as a decimal, or 850. In both cases, my selling price does work out to be $850. That is an expensive suit, but hopefully one that's well worth it. All right, looking at 8.7, we're going to talk about finding the cost when we have a percent markup based on selling price. This is most useful, as I mentioned earlier, when you know how much money customers will pay for an item. It allows the retailer, the forward-facing sales, to target the cost of an item in order to maximize their markup. So all we're going to do for this is rearrange the formula from 8.6. We know that the selling price is the cost divided by the complement of the markup. If we just multiply both sides by that denominator, the complement of the markup, we get that the cost is the selling price times 100 minus the percent markup based on selling price, or a piece of the formula we already had in order to solve to get the selling price. Now, to use this, Susie knows the market will not pay more than $25 each for her amigurumi pieces. If her goal is a 72% markup based on her selling price, what should her costs be? So as usual, I can use the table or the chart if I'm comfortable and familiar with it. I just need to remember that the 100% goes where? If she wants a markup based on selling price, the 100 has to go where the selling price is. Now, we know her selling price should be $25. You can tell. I need to fix that one. There we go. That should be 25. Let's hope this turns out the way I think it should. Now, we know her markup percent is 72. That means that her cost should be no more than 28%. I'm supposed to find her cost. So cost is my X. Using the first row and the last row, I can set up a proportion that says X over 25 is 28 over 100. Good. I fixed the 8 in one place, but not in the other. So I should have X over 25 is 28 over 100. When I cross multiply, I will have X times 100 and 25 times 28. So 100X is equal to 700, which means my X value has to be 7. Using the formula that I just figured out, I know cost should be the selling price times 100 minus the markup based on selling price. 100 minus. Why did I have a plus in there? That should be a minus. All right, let's see if I did it right the next time. I think I did. So my selling price is $25, and then I've got 100 minus 72%, which is 28%, or 25 times 0.28, which, yes, works out to be $7. So the cost of this item should be no more than $7. Now, just because I find it interesting and because my name is kind of in it, amigurumi, in case you were curious as to what it is one of my favorite little pastimes. It's a part of Japanese culture. You make adorable little crocheted stuffed animals. It should be noted that it takes approximately 1 to 2 hours to crochet even the simplest of amigurumi pieces, which means if her cost is $7 and she's including her labor, she's getting paid less than $3 an hour. So I hope she's not including her labor in that. All right, converting. So this is the last piece, and these are two simple formulas that help you convert from markup based on selling price to markup based on cost. So if you have the markup based on cost and you need to convert that, so this is known, the markup based on cost is known, and you want to convert to the markup based on selling price, you would take the markup based on cost and divide it by 100 plus that markup based on cost, because your selling price is your markup based on cost plus 100%. If you have the markup based on selling price and you're converting that to the markup based on cost, so the markup based on selling price is given and you're going to convert it to markup based on cost, then you want to take the known markup based on selling price and divide it by the complement or its complement, 100 minus the markup based on selling price. And that's because what this is giving you really is your cost percent. It's really giving you the percent cost. It's worth noting that the markup based on cost will always be greater than the corresponding markup based on selling price. But why is that? Can your markup based on selling price ever be more than the actual selling price? Can you mark up an item more than its cost? All right, let's try the next one. So let's try a few examples of this. Kate Spade purses are marked up 500% based on their cost. What is the corresponding markup based on selling price? So in this particular case, our markup based on cost is known. Our markup based on selling price is what's being requested. In that case, the markup based on selling price is equal to the cost percent divided by 100 plus the cost percent. So this would be 500% divided by essentially 600%, or 5/6, which when you divide that out is 0.83 repeating. Converting this to a percent, we would multiply by 100, and depending upon how they want the answer, this would be 83 1/3%, or 83.3 repeating percentage. Now, there is some expectation here that you recognize that a repeating 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3 is 1/3. That a repeating 6, in other words, if it had been 86.66666666, is 2/3. Let's try one going the other direction. So the next one says that Amazon sells a Bose soundbar at a 66% markup based on the selling price. What is the corresponding markup based on the cost? And we need to round to the nearest 1/10 of a percent. So markup based on selling price is known. Markup based on cost is what's requested. So if we know the markup based on selling price, then to find the markup based on cost, we've got to take the markup based on selling price and divide it by its complement. So that'll be 66% divided by 100 minus 66%, or 66% over 33%. 0.66 divided by 0.34 is 1.941176. When I multiply this by 100 to get the percent again, I'll have 194.1%. This would be the markup based on cost. All right, so here we have some practice. I'm just going to take a minute and click through these. The markup based on cost is given. The conversion is to markup based on selling price. So this would be the cost percent divided by 100 plus, or 0.33 divided by 1.33, which is 0.24812, or 24.8%. Likewise, the next one would be 0.8 divided by 1.8, which is 0.4 repeating. This is 44.4%. The next one would be 225% divided by 100 plus that, or 325%, for 0.69231, or 69.2%. And lastly, if we had 100% markup, that is, if our markup was the same amount as our cost, this would be 100 divided by 200, or 1 divided by 2, which is 0.5, or a 50% markup based on selling price. That makes perfect sense to me. If I'm doubling what I cost, so if I'm keystoning it, then essentially my markup compared to the selling price would be half of it. And we kind of said that with keystoning, right? Keystoning means you've doubled your cost, so your cost is half of your selling price. All right. If we've got the markup based on selling price and we're converting it to markup based on cost, we divide by the complement. So this would be 0.11 divided by 0.89, or 12.4%. We round that off to the nearest 10th. 25% would be divided by its complement of 75%, which would be a 0.3 repeating, or 33 1/3%. 58% would be divided by its complement of 42%. That would give us a 1.38, or 138.1%. And 90% would be divided by its complement of 10%. And this signifies a 900% markup based on cost. All right, so we have reached the end of this one. So this is where we do a little bit of a check. Do you feel confident? Can you calculate the percent markup based on selling price? Do you feel like you can calculate the selling price when the cost is known and your percent markup based on the selling price is known? Can you calculate the cost of an item when your selling price is known and the percent markup based on selling price is known? Are you comfortable converting between markups? Can you convert the percent markup based on cost 2% markup based on selling price, and you convert the markup based on selling price to a markup based on cost. There is in your e-text some additional practice. Chapter 8, Section 2, the review exercises. I believe there are 23 questions in there. And I'm not sure where that is in the physical copy of the book, but again, if you go to Chapter 8, Section 2, and you go to the back of that section to the review exercises, you will find a problem set there to do. Your graded assignment can be found on WebAssign, and it is creatively titled Chapter 8, Section 2. If you have any additional questions or concerns, please do not hesitate to contact your instructor, your embedded math support. The Math Center is also available for questions, and any tutor you may have available to you. Have a good night.